In the early morning hours of March 15, 1962, 11 coal miners descended into the depths of the Clearwater Mine in southwestern Pennsylvania, unaware that a catastrophic fire would trap them underground for nearly 18 hours before claiming their lives. Before we continue, please note, this is a fictional story based on various reports and accounts. This content contains sensitive material and is intended for entertainment and educational purposes only. The Clearwater Coal Mine sits nestled in the rolling hills of Westmoreland County, Pennsylvania, approximately 40 miles southeast of Pittsburgh. On that fateful March morning, the temperature hovers at 32 degrees Fahrenheit as the day shift arrives at the mine entrance. The facility operates as a deep shaft mine, extending nearly 800 feet below ground through a network of tunnels and chambers carved into the Pittsburgh coal seam. The mine employs 47 workers across 3 shifts, extracting approximately 2,000 tons of bituminous coal daily for the regional steel industry. Clearwater Mine represents a typical mid-sized operation of the early 1960s, utilizing conventional room and pillar mining techniques combined with mechanical loading equipment. The main shaft descends vertically before branching into horizontal drifts that follow the coal seam. Ventilation systems pump fresh air down through the main shaft and exhaust stale air through a secondary shaft located 600 yards from the primary entrance. The Clearwater Mine begins operations in 1947 under ownership of the Allegheny Coal Corporation, a regional mining company with 12 facilities across western Pennsylvania. The mine's safety record during its first 15 years of operation remains relatively clean compared to industry standards. Federal mine inspectors document only 3 serious incidents between 1947 and 1961: a roof collapse in 1952 that injures 2 workers, a methane gas accumulation event in 1956 that forces temporary evacuation, and a conveyor belt accident in 1959 that results in 1 fatality. The facility operates under regulations established by the Federal Coal Mine Safety Act of 1952, which mandates specific ventilation requirements, gas monitoring procedures, and structural safety standards. State inspectors from the Pennsylvania Department of Mines conduct quarterly safety reviews, while federal inspectors perform annual comprehensive examinations. The mine maintains certification for all required safety equipment, including methane detectors, carbon monoxide monitors, emergency breathing apparatus, and fire suppression systems. Clearwater's ventilation system follows standard industry design, utilizing a primary intake shaft equipped with a centrifugal fan capable of moving 60,000 cubic feet of air per minute through the underground workings. The exhaust system employs a secondary shaft with an additional fan unit that maintains negative pressure to ensure proper air circulation. Underground air monitoring stations positioned throughout the mine network continuously measure methane concentrations, oxygen levels, and carbon monoxide presence. The mine's electrical infrastructure includes a main power distribution center located at the surface, feeding underground substations through armored cables installed in dedicated cableways. All underground electrical equipment meets explosion-proof standards required for coal mining operations. Emergency power systems include battery-operated lighting units and communication equipment positioned at strategic locations throughout the mine. Fire prevention protocols require daily inspections of all electrical equipment, monthly testing of fire suppression systems, and quarterly reviews of combustible material storage procedures. The mine maintains fire suppression equipment including water hoses, foam generators, and rock dust barriers designed to prevent coal dust explosions. Emergency evacuation procedures mandate that all workers know the location of self-contained breathing apparatus units and escape routes to the surface. Coal extraction operations utilize continuous mining machines that cut coal from the face and load it onto conveyor systems for transport to the main shaft. The mine processes coal through mechanical preparation facilities at the surface, removing impurities and sizing the product for shipment to steel mills and power plants throughout the region. Production targets call for extracting coal from multiple working faces simultaneously to maintain daily output quotas. The day shift crew on March 15th includes 11 miners working in the deepest section of the mine, approximately 700 feet below ground. Shift supervisor William Morrison, a 22-year veteran of coal mining operations, oversees the crew's activities from his station near the main working face. Lead miner Robert Kowalski operates the continuous mining machine, while transport operator James Sullivan manages the conveyor belt system that carries coal to the main shaft. Safety Inspector Thomas Bradley conducts his routine morning inspection of electrical equipment and ventilation systems. Maintenance workers David Chun and Michael O'Brien perform scheduled repairs on mining equipment. The remaining crew members include miners Frank Rodriguez, Anthony Petrosky, Eugene Novak, Carl Lindbergh, and Stephen Wojcik, each assigned to specific tasks including roof bolting, coal loading, and equipment operation. The week preceding the accident reveals several concerning maintenance issues that contribute to the eventual disaster. On March 8th, electrical technicians report intermittent power fluctuations in the underground distribution system, attributed to aging cable connections in the main feeder line. Maintenance records indicate temporary repairs using electrical tape and wire nuts rather than proper splice connections, a practice that violates federal safety standards but allows continued production. Ventilation system performance shows declining efficiency during the same period. Airflow measurements taken on March 10th record only 52,000 cubic feet per minute through the main intake, well below the required 60,000 cubic feet minimum. The reduction results from accumulated coal dust blocking air passages and a partially damaged fan blade in the primary ventilation unit. Mine management schedules repairs for the following week to avoid production delays. Coal dust accumulation reaches dangerous levels in several underground areas by March 12th. Federal regulations require rock dust application to reduce coal dust concentrations below 20%, but recent measurements show concentrations exceeding 30% in multiple locations. The mine's rock dusting equipment experiences mechanical problems, delaying scheduled dust suppression activities. Methane monitoring equipment begins showing irregular readings on March 13th. Gas detection instruments in the deepest working areas record fluctuating methane levels between 0.8 and 1.2%, approaching the 1.5% threshold that requires immediate evacuation. However, instrument calibration records indicate the detectors have not received proper maintenance for 6 weeks, raising questions about reading accuracy. The continuous mining machine develops hydraulic fluid leaks on March 14th, creating puddles of flammable liquid near electrical equipment. Maintenance crews attempt temporary repairs using hydraulic hoses and clamps, but fluid continues seeping onto the mine floor. Standard procedure requires shutting down equipment for proper repairs, but production pressures lead to continued operation with makeshift fixes. Emergency equipment inspections reveal additional deficiencies in the days before the accident. Several self-contained breathing apparatus units show expired air cartridges, while others have damaged face masks or faulty pressure gauges. Fire suppression equipment includes water hoses with deteriorated connections and foam generators lacking proper chemical supplies. The sequence of failures begins with the deteriorating electrical infrastructure that mine management chooses to patch rather than properly repair. The temporary electrical connections installed on March 8th create high-resistance joints that generate excessive heat under normal operating loads. These connections, located in a junction box approximately 500 feet underground, begin failing intermittently as thermal cycling weakens the makeshift repairs. The compromised ventilation system exacerbates the electrical problems by allowing coal dust to accumulate around electrical equipment. Reduced airflow fails to carry away heat generated by electrical components, causing junction box temperatures to rise above safe operating levels. The combination of heat buildup and coal dust creates ideal conditions for ignition. Methane gas accumulation adds another critical element to the developing hazard. The faulty monitoring equipment masks the true extent of gas buildup in the deepest mining areas. Actual methane concentrations reach nearly 2% in some locations, well above the explosive threshold, but malfunctioning detectors fail to trigger evacuation alarms. The hydraulic fluid leaks from the continuous mining machine create an additional ignition source and fuel supply. Pressurized hydraulic fluid atomizes when released, forming a fine mist that burns rapidly when exposed to ignition sources. The leaked fluid also soaks into coal dust on the mine floor, creating a combustible mixture that spreads the fire once ignition occurs. Mine management's decision to continue operations despite multiple safety deficiencies reflects the economic pressures facing the coal industry in 1962. Production quotas and delivery contracts create financial incentives to maintain operations even when safety systems require attention. The practice of implementing temporary fixes rather than proper repairs becomes standard procedure, accumulating risk over time. Federal inspection procedures also contribute to the developing hazards. The most recent comprehensive safety inspection occurs 6 months before the accident, missing the recent deterioration in electrical and ventilation systems. Quarterly state inspections focus primarily on structural safety rather than electrical or atmospheric hazards, allowing dangerous conditions to develop undetected. The mine's emergency response planning proves inadequate for the type of fire that eventually occurs. Evacuation procedures assume workers have sufficient warning time to reach escape routes, but the rapid spread of fire and smoke prevents orderly evacuation from the deepest working areas. At 6:47 a.m. on March 15, 1962, the electrical junction box located in the main haulage way 500 feet underground experiences catastrophic failure. The overheated temporary connections finally break down completely, creating an electrical arc that ignites accumulated coal dust around the junction box. The initial fire spreads rapidly along electrical cables, consuming insulation and spreading to nearby wooden support structures. Within 3 minutes, the fire reaches the hydraulic fluid leak from the continuous mining machine. The pressurized hydraulic system ruptures completely at 6:50 a.m., spraying flammable fluid throughout the immediate area and creating a massive fireball that extends across the entire width of the tunnel. The explosion damages ventilation ducting and destroys electrical cables supplying power to the emergency communication system. The fire spreads in 2 directions simultaneously. Moving toward the main shaft, flames consume conveyor belt materials and wooden cribbing used for roof support. The synthetic rubber conveyor belt produces dense black smoke containing toxic gases, including carbon monoxide, hydrogen sulfide, and various organic compounds. Moving away from the main shaft, the fire advances through the tunnel system toward the deepest working areas where the 11-man crew operates. By 6:55 a.m., the fire has traveled nearly 200 feet from the ignition point. Methane gas accumulated in poorly ventilated areas begins igniting, creating secondary explosions that propagate the fire through previously unaffected tunnels. The compromised ventilation system fails to contain the fire and actually feeds it with oxygen while spreading toxic smoke throughout the underground workings. The crew working in the deepest section first becomes aware of the emergency at 6:58 a.m. when Supervisor William Morrison notices smoke entering their work area through the main air intake. Morrison immediately orders the crew to shut down all electrical equipment and begin evacuation procedures. However, the primary escape route back to the main shaft is already blocked by fire and smoke. At 7:02 a.m., the crew attempts to reach an alternative escape route through a secondary tunnel system. This route requires traveling through older workings that have limited ventilation and narrow passages. The crew discovers that smoke has already penetrated this area, making visibility extremely poor and breathing dangerous without respiratory protection. Morrison leads the crew to a refuge chamber located approximately 800 feet from their work area. These chambers, required by federal safety regulations, contain emergency supplies including breathing apparatus, water, and communication equipment. However, the crew finds that several breathing units have expired air supplies, and the emergency telephone system has lost power due to fire damage. Between 7:15 and 7:30 a.m., the crew attempts to establish radio contact with surface personnel using portable communication equipment. Static and interference from the fire prevent clear communication, but they manage to transmit their general location and the number of trapped personnel. Surface rescue teams begin assembling, but require time to assess fire conditions and plan safe entry routes. The fire continues expanding throughout the mine network. By 7:45 a.m., flames have consumed nearly half a mile of conveyor belt system and spread to multiple working faces. Coal dust explosions occur intermittently as the fire encounters areas with high dust concentrations, creating pressure waves that damage ventilation systems and spread burning material to new locations. Smoke concentration in the refuge chamber begins increasing at 8:20 a.m. as the fire overwhelms the mine's ventilation capacity. The crew attempts to seal air leaks using available materials, but smoke continues entering through cracks in the rock walls and damaged ventilation ducts. Carbon monoxide levels rise steadily, requiring the crew to use emergency breathing apparatus with limited air supplies. At 9:15 a.m., rescue teams make their first attempt to reach the trapped crew using the secondary tunnel system. Intense heat and smoke force them back after advancing only 300 feet underground. Fire suppression efforts from the surface prove ineffective due to the fire's location deep within the mine and the damaged water distribution system. The crew's situation deteriorates throughout the morning as air quality continues declining. Emergency breathing apparatus units provide only 30 minutes of air each, forcing crew members to share equipment and limit physical activity to conserve oxygen. Communication attempts become increasingly sporadic as portable radio batteries drain and smoke interferes with signal transmission. By noon, surface rescue teams recognize that direct access to the trapped crew is impossible while the fire continues burning. They begin implementing alternative strategies, including drilling ventilation holes from the surface and pumping inert gas into the mine to suppress combustion. However, these efforts require several hours to complete and may not reach the refuge chamber in time. The fire reaches its peak intensity between 1 o'clock and 3 p.m., consuming remaining combustible materials throughout the affected mine sections. Temperatures in some areas exceed 1,500 degrees Fahrenheit, causing rock spalling and structural damage to tunnel walls. The intense heat creates convection currents that spread toxic gases throughout the mine network. Rescue operations continue throughout the afternoon, with multiple teams attempting different approach routes. Each attempt meets heavy smoke and dangerous gas concentrations that prevent reaching the trapped crew. Surface personnel maintain continuous communication attempts, but receive no responses after 2:30 p.m., when the crew's portable radio equipment finally fails completely. The initial emergency response begins at 7:05 a.m. when surface personnel notice smoke emerging from the main ventilation shaft. Mine foreman George Patterson immediately activates the emergency alarm system and begins accounting for all personnel. The surface crew confirms that 11 workers remain underground in the affected area, while 36 other employees successfully evacuate through unaffected escape routes. Local fire departments from 3 surrounding communities respond to the emergency call at 7:18 a.m. However, their standard firefighting equipment proves inadequate for underground mine fires. The fire department focuses on preventing surface spread, while specialized mine rescue teams mobilize from regional locations. The Pennsylvania Bureau of Mines dispatches emergency response specialists at 7:30 a.m., but the nearest qualified mine rescue team requires 3 hours to reach the site with proper equipment. Federal mine safety inspectors also respond, but their role focuses on investigation rather than immediate rescue operations. Emergency medical services establish a treatment area near the mine entrance to care for evacuated workers suffering from smoke inhalation. 3 miners require hospitalization for respiratory problems, while others receive treatment for minor injuries sustained during evacuation. Mine rescue teams attempt multiple entry strategies throughout the day. The first approach uses the main shaft with breathing apparatus and fire suppression equipment. However, intense heat and smoke force retreat after advancing only 200 feet underground. Subsequent attempts through alternative shafts and tunnel systems meet similar obstacles. Surface teams implement emergency ventilation procedures by reversing fan systems to exhaust smoke and toxic gases. This strategy provides some improvement in air quality, but also feeds oxygen to the fire, creating a difficult balance between life support for trapped miners and fire suppression requirements. Communication efforts include attempts to establish contact through existing mine telephone systems, portable radio equipment, and emergency signal devices. Rescue teams also attempt to communicate by tapping on pipes and metal structures, but receive no responses from the trapped crew after early afternoon. All 11 miners trapped in the deepest section of the Clearwater mine perish from carbon monoxide, poisoning, and smoke inhalation. Recovery operations begin 18 hours after the initial fire when temperatures cool sufficiently to allow rescue team entry. The crew members are found in the refuge chamber where they attempted to wait for rescue, with evidence suggesting they survived for several hours before succumbing to toxic gas exposure. The victims include Supervisor William Morrison, age 44, with 22 years of mining experience, lead miner Robert Kowalski, age 38, father of 3 children, transport operator James Sullivan, age 29, recently married, safety inspector Thomas Bradley, age 52, nearing retirement, maintenance workers David Chun, age 33, and Michael O'Brien, age 27, and miners Frank Rodriguez, age 25, Anthony Petrosky, age 41, Eugene Novak, age 35, Carl Lindbergh, age 30, and Stephen Wojcik, age 26. Property damage from the fire totals approximately $2.3 million in 1962 dollars. The fire destroys nearly 1 mile of conveyor belt systems, damages electrical infrastructure throughout the affected mine sections, and requires extensive reconstruction of ventilation systems. Heat damage compromises structural integrity in several tunnel areas, necessitating additional roof support installation. Environmental impact includes groundwater contamination from fire suppression chemicals and smoke emissions that affect air quality in surrounding communities. The mine closure eliminates 47 jobs and reduces local coal production capacity by approximately 500,000 tons annually. The comprehensive investigation conducted by federal mine safety officials, state regulatory agencies, and independent safety experts identifies multiple contributing factors to the tragedy. The primary cause involves the electrical system failure resulting from improper temporary repairs that created high-resistance connections generating excessive heat. Technical examination of the failed junction box reveals that makeshift electrical connections using wire nuts and electrical tape could not handle the amperage requirements of mining equipment. These connections reached temperatures exceeding 200 degrees Fahrenheit before failing completely and creating the ignition arc that started the fire. Ventilation system analysis shows that reduced airflow allowed dangerous accumulations of coal dust and methane gas throughout the affected mine areas. The compromised ventilation also prevented effective smoke removal during the fire, contributing to the toxic atmosphere that claimed the miners' lives. Investigation of the methane monitoring equipment reveals calibration errors that understated actual gas concentrations by as much as 40%. Proper calibration would have detected dangerous methane levels and required evacuation before the fire occurred. The hydraulic fluid leak investigation determines that temporary repairs using inadequate hoses and clamps created a pressurized fuel source that dramatically accelerated fire spread. Proper shutdown and repair procedures would have eliminated this hazard. Expert testimony during investigation hearings criticizes mine management's decision-making process that prioritized production over safety maintenance. Documentation shows that management was aware of multiple safety deficiencies but chose temporary fixes to avoid production delays. Federal investigators also identify inadequacies in emergency response planning and equipment maintenance. Many self-contained breathing apparatus units contained expired air supplies, while communication systems lacked backup power sources to function during electrical failures. The investigation reveals systemic problems with inspection procedures that focus on periodic reviews rather than continuous monitoring of safety conditions. The 6-month interval between comprehensive federal inspections allows dangerous conditions to develop undetected. Legal proceedings result in federal safety violations against the Allegheny Coal Corporation totaling $847,000 in fines, the largest penalty assessed against a coal mining company at that time. The company also faces wrongful death lawsuits filed by families of the deceased miners, ultimately paying $3.2 million in settlements. Federal legislation passed in 1963 mandates more frequent safety inspections, improved electrical safety standards, and enhanced emergency communication systems for underground coal mines. The new regulations require monthly electrical system inspections and prohibit temporary repairs that do not meet permanent installation standards. Ventilation system requirements receive significant updates, including mandatory backup ventilation capacity and continuous air quality monitoring systems. Coal dust control regulations become more stringent, requiring weekly dust measurements and immediate corrective action when safe levels are exceeded. Emergency preparedness standards undergo major revisions, including requirements for redundant communication systems, improved refuge chamber supplies, and enhanced rescue team training programs. All underground personnel must complete annual emergency response training and demonstrate proficiency with breathing apparatus equipment. The Pennsylvania Department of Mines implements new inspection protocols that include unannounced safety reviews and real-time monitoring of critical safety systems. State inspectors receive additional training on electrical hazards and atmospheric monitoring techniques. Industry-wide safety improvements include development of better methane detection equipment, flame-resistant conveyor belt materials, and improved fire suppression systems specifically designed for underground coal mines. Equipment manufacturers invest in research to develop intrinsically safe electrical components that cannot create ignition sources. The Clearwater Mine fire demonstrates the critical importance of maintaining electrical safety systems in underground coal mining operations. Temporary repairs that compromise electrical integrity create unacceptable risks in environments containing combustible gases and coal dust. The investigation establishes new industry standards requiring that all electrical work meet permanent installation criteria regardless of production pressures. Ventilation system maintenance emerges as another crucial factor in mine safety. Adequate airflow serves multiple safety functions including methane dilution, coal dust removal, heat dissipation, and smoke evacuation during emergencies. Regular ventilation system testing and immediate repair of deficiencies become standard industry practices following this incident. The accident highlights the interconnected nature of mine safety systems, where failure in one area can cascade into multiple hazards. Electrical problems led to ignition sources, while ventilation deficiencies allowed hazardous accumulations and prevented effective emergency response. This understanding leads to integrated safety management approaches that consider system interactions. Emergency preparedness planning requires realistic assessment of evacuation scenarios and refuge capabilities. The Clearwater incident shows that workers may become trapped despite following proper procedures, necessitating improved refuge facilities and rescue capabilities. Modern mine emergency plans include detailed scenarios for various types of incidents and multiple response strategies. The tragedy underscores the importance of accurate safety monitoring equipment and proper maintenance procedures. Faulty gas detection instruments provide false security that allows dangerous conditions to develop unnoticed. Current industry standards require redundant monitoring systems and frequent calibration verification. If you're interested in stories like this, make sure to subscribe for more in-depth investigations into industrial accidents and safety improvements. Hit the like button if you're finding this story compelling, and share this video with others who appreciate detailed analysis of how industries learn from tragedy to prevent future incidents. The legacy of the Clearwater Mine fire continues influencing coal mining safety practices 60 years later, serving as a reminder that production pressures must never compromise the fundamental responsibility to protect worker safety through proper maintenance, monitoring, and emergency preparedness.